Okay, so for years, engineers, especially data engineers, you know the scene. The terminal, that's a command center, right? Stark, powerful. It's where the real work happens. And yeah, we've seen loads of AI coding tools pop up, but honestly, they've often felt a bit like guests. Clunky plugins, maybe, or you've got another web tab open. They don't really belong there, but that might be changing. Today, we're really digging into Anthropic's Claude Code. It launched back in February 2025, got a big update with 4.0 in May, and the claim is huge. It doesn't just visit the terminal, it lives there, sets up shop. So you hear phrases like paradigm shift, quantum leap for data engineering. Big words. Let's unpack that. What really makes it different? Why is this supposedly such a game changer, especially now?
That's exactly the right question. Because, look, the complexity data engineers deal with daily is, well, it's immense. You're juggling different scripts, databases, cloud infrastructure, you name it. It's this whole intricate web. So a tool that doesn't just help from the outside, but actually integrates into that core workspace, the terminal. It's not just nice to have. It could genuinely change the whole workflow, smooth out so much friction.
Right. And that key difference, that living their idea, it comes down to a specific design choice, doesn't it? It's not just another IDE extension, not some chatbot in a browser. It's actually a native command line tool.
Exactly. That's the core design decision, and kind of profound, really, because it lives in the terminal. It just works.
Yeah.
Everywhere. Your local VS Code terminal,
Yep.
an SSH session into a production server halfway across the world,
Yep.
even just a basic shell. It's there. That seamlessness, that lack of context switching, that's key.
Okay, and this power comes from what they call agentic capabilities. Sounds a bit sci-fi, maybe. For an engineer at the keyboard, what does agentic actually mean day to day? How's it different from, say, really good autocomplete?
Yeah, good question, because it's way beyond autocomplete. Think of it more like an active, intelligent collaborator. It uses something called agentic search. And what that lets it do is understand your entire code base, like conceptually. It can then plan and execute multi-step tasks, with you supervising, of course. So it sees how your Python scripts connect to your SQL, how your DBT models fit in, the Docker files, the Terraform configs, all of it. You don't have to spoon feed it the context. It grasps the whole picture, the relationships between everything. And that holistic view, that's been the missing piece in AI assistants before now.
So it's not just seeing the line, it's seeing the whole architectural blueprint.
Got it. Now, data engineers, they're building and maintaining these digital circulatory systems, right, the data pipelines, often super complex, sprawling things. How does Claude Code actually help manage that delicate dance? Can you give us some concrete examples? Where does it really make a difference?
Oh, absolutely. Let's talk wrangling complex pipelines. Think about a standard ETL or ELT process extract transform load model. Say you need to add just one new field, like a customer tier, to a final DBT model, maybe FD monthly sales previously. That meant manually hunting down and editing potentially multiple files. SQL queries, Python scripts, the DBT model itself. It's tedious and super easy to introduce subtle bugs.
Yeah, I can see that. Nightmare fuel. Right. So with Claude Code, you give it one natural language prompt, something like add the customer tier field from the source through to the FD monthly sales DBT model. And then it traces the data lineage. It finds all the relevant files. It modifies the SQL extraction, adjusts the Python transformation script, maybe for data types, updates the target table schema, and updates the DBT model, all while keeping the context consistent. It avoids those little errors that cause big headaches later.
Okay, that's impressive. What about when things inevitably break?
Debugging.
Debugging.
Yeah.
Especially debugging at scale. Everyone knows the pain of that 3 a.m. alert when a pipeline fails. Before, you're frantically digging through logs, trying to find the needle in the haystack. It could take hours.
Total scramble. Exactly. Claude Code changes that from a scramble to more of a proactive investigation. You can literally ask it, hey, analyze the failure in the nightly data load airflow DAG. What's the root cause?
Yeah.
It can parse the logs, find the exact failing task, jump to the specific script, figure out the problem, maybe a null value, a bad join, an API changed unexpectedly, and then, crucially, it suggests the fix. And it can even implement it with your OK.
So hours, potentially down to minutes?
Potentially, yeah. It's
Where's-
a massive time compression. Saves a lot of stress.
Okay, one more area. Infrastructure. Data engineers seem to be doing more infrastructure as code now. Terraform, Docker.
Definitely. That's a growing part of the role. And Claude Code acts almost like an expert pair programmer for that stuff.
Yeah.
It helps you write cleaner Terraform, spot errors in your Docker files. It can even look at some crusty old script someone wrote years ago and explain what on earth it's actually doing.
Demystifying the legacy code. Always helpful.
It really is. It's like having a senior engineer looking over your shoulder, but one that also explains the why. not just the what.
Okay, so these examples, they paint a really compelling picture of, well, efficiency, speeding things up. But how real is this? Is the performance actually there? What's the proof it's reliable and genuinely accelerates things beyond just, hype?
Fair question. And yeah, the proof is in the performance. This isn't just smoke and mirrors. It's driven by the reasoning power of the underlying Claude Sonnet models. It's not just pattern matching. It's understand the logic of the code at a deeper level. And that leads to better, more reliable output. For instance, in benchmarks looking at security, which is obviously huge when you're handling data, Claude Code did exceptionally well. It hit an F1 score of nearly 0.9 in vulnerability detection. That's significantly better than, say, GPT 3.5 Turbo. It's much better at catching things like SQL injection risks or iffy data handling before they cause real problems.
Okay, so better security. What about raw speed?
Anthropic's own tests showed it completing complex engineering tasks, stuff that would normally take a human maybe 45 minutes of focused effort in a single pass. They talk about a hybrid reasoning approach, allowing this more nuanced understanding. It just gets the job done faster and often more accurately in the first try.
That kind of acceleration, yeah, that sounds like it could genuinely change things, frees up engineers from the tedious stuff. But let's be real, are there any downsides, any hidden challenges, or maybe tasks where it still struggles, where the human touch is still way better?
That's a good point. No tool is perfect, right? Integration isn't always instant magic. You might need to tweak things a bit depending on how your project is set up. And you have really, really messy or undocumented legacy code, well, it might need more human hand-holding initially. The learning curve isn't so much about using the tool, but more about learning to trust it and prompt it effectively. How do you best leverage that agentic capability? It's a bit of a shift in mindset, moving from just telling it what to do to collaborating on solving the problem.
Shifting from instruction to collaboration. Makes sense.
But the upside is clear. Less time on bugs, more time on architecture, innovation. The interesting stuff.
Okay, but giving an AI this much power, especially near production data, that's got to raise some security eyebrows. How does Anthropic stop it from, running amok? What are the guardrails?
Absolutely critical concern. Security is baked in. First, it connects directly to Anthropic's API. No intermediary servers hanging around, which reduces the attack surface. But the most important thing, the real safeguard, is the principle of explicit consent. Meaning Claude Code will never change a file, never execute a command unless the engineer explicitly tells it to. Clicks approve, basically.
Yeah, okay. Human in the loop. Always.
Always. It's a supervised agent, not a rogue one. That gives teams the confidence to use its power, but maintain absolute control. It's not going off doing things on its own.
Right. And that interaction model must change how you work with it, too.
Definitely. It feels less like using a static tool and more like pair programming. But with a colleague who knows almost everything and never gets tired, it can explain why it's suggesting something, document the changes it makes, even help new team members get up to speed on a complex project just by interacting with it. It accelerates understanding, not just coding.
Okay, so let's be crystal clear then. This isn't just a better GitHub Copilot or Tab9. Those are great for autocomplete, predicting the next few characters.
Exactly. Those operate mostly at the line level. Claude Code is playing a different game. It's more like a strategic partner. It understands the entire repository. It executes complex tasks across multiple files and languages. That terminal native design, combined with the agentic architecture, that's its real edge for the kind of interconnected work data engineers do.
So a supervised agent.
Precisely. It enhances human expertise. It doesn't replace it. It handles the grunt work, the tedious bits, the cross-file complexity. It's really about creating this synergy between human intelligence and machine intelligence, letting engineers focus on the big picture challenges, designing those robust, scalable, truly insightful data systems.
It really sounds like the agentic age is here, and for data engineering, the command center is still the command center, just with a much smarter copilot. So wrapping up, we've seen Claude Code basically move AI from being that temporary guest in the terminal to being a full-time integrated resident. And that seems to fundamentally shift the data engineering workflow.
Yeah, and if you zoom out a bit, connect it to the bigger picture. This move towards supervised agents is really interesting. You have AI handling the toil, the complex debugging, because it understands the whole context. That really starts to reshape what we value in human intelligence, doesn't it? Not just in data engineering, but across software development, maybe even other technical fields. It raises this big question. If the machine tackles the routine, the tedious, even a lot of the complex but solvable problems, where does human ingenuity become most critical in this new agentic age? What's our unique value add?
That's definitely something to think about. And for everyone listening, how could this kind of model, that synergy of human intellect and machine intelligence, change the challenges you face in your field and your day-to-day work? Something to mull over.